Welcome to this tutorial, where we'll explore how to control player speed in Unity using the update function. This video is designed specifically for beginner Unity developers. The update function is a core concept in Unity called every single frame. This makes it perfect for handling continuous actions, such as player movement and input processing, ensuring smooth and responsive gameplay. First, let's set up our project. Begin by creating a new Unity project or opening an existing one. We'll need a simple 3D environment to test our player movement. Next, create a basic player object, such as a cube or capsule, and place it on the ground plane. To enable physics-based interactions, add a rigid body component to your player object. Now, create a new C# script named player movement and attach it to your player object. This script will contain all the logic for controlling our player's speed. Open the player movement script in Visual Studio. You'll see the basic structure, including the start and update functions. We'll focus our coding efforts within the update function. Declare a public float variable for player speed. For example, public float move speed equals 5f. This allows us to easily adjust the speed directly from the Unity editor. Inside the update function, we'll get input from the player using input.getAxis and input.getAxis. These functions return values between -1 and 1 based on keyboard or joystick input. Next, create a movement vector based on this input. Vector3 movement equals new vector3. This vector defines the direction of player movement. To move the player, use transform, translate. This method applies the movement vector to the player's current position. It's crucial to multiply by time.delta time. This ensures frame rate independence, meaning your player moves at the same speed regardless of the computer's performance. Now, back in the Unity editor, you can modify the move speed variable in the inspector to instantly change your player's speed. Experiment with different values to see the effect. Let's add a sprint feature. Introduce a multiplier for speed when a specific key, like left shift, is pressed. This allows for dynamic speed changes during gameplay. Then, update the transform. Translate line to use current speed instead of move speed. This applies the adjusted speed, whether sprinting or not. For smoother movement, we can implement acceleration and deceleration. This makes the player's speed gradually change rather than instantly snapping to a new value. Declare current speed, acceleration, and deceleration variables. We'll use these to control how quickly the player reaches their target speed. Inside update, use math that move towards to gradually change current speed. If there's input, accelerate towards move speed. Otherwise, decelerate towards 0. Adjusting the acceleration and deceleration variables in the Unity editor allows you to fine-tune the feel of your player's movement, making it more responsive or weighty. Adding comments to your code is essential for readability and maintainability. They explain what each section does, making it easier for you and others to understand later. For example, a comment like // speed of the player movement clearly describes the purpose of the _speed variable, improving code clarity. In summary, we've covered using the update function for continuous movement, handling input, implementing basic speed control, and adding smooth acceleration and deceleration. We also emphasize the importance of time.delta time for frame rate independence and adding comments for better code readability. These are fundamental practices for any Unity developer. We encourage you to experiment with different values for speed, acceleration, and deceleration to achieve the desired feel for your player's movement. Practice is key to mastering these concepts. Consider exploring further topics like implementing jumping, camera controls, or more complex movement mechanics. The principles learned here form a strong foundation for advanced player control.